Hey everybody. So the computer Porta Cube system is currently home for the weekend because at my place of work last week we had a power outage, and the outage lasted for probably a couple hours or so, and when the power was restored I was not able to start this thing up. The 5-volt standby rail would not come up. And I was able to get it to start up using a little hack as shown in a previous video, but we need to actually fix this. So normally the fix will be to replace the power supply. Now if you don't have experience with electronics repair and soldering, then yeah, that would be the option. But what we'll fix is power supply. It's just a matter of replacing one particular capacitor. So I'm going to pull the cover off this system and I'm going to remove the power supply. That way we can repair it. One thing I do not like about this particular case is this cover. It's such a pain to get back on. Whereas the Ultra Microfly MX6 has a 3-piece cover. It's a whole lot easier to work with. But anyways, here we are inside and there's our power supply. It is a Bestec ATX-300-12E power supply that was originally from a 2008 ink machine system. I recapped it some time ago using harvested motherboard caps, and it spent several years post recap in a refurbished computer, and then when the customer / client upgraded, I got the refurbished system back, and now this power supply for the past year and change has been powering the Porta Cube system. Alright, so let's go ahead and pull this out of here. Okay, it's a matter of popping several zip ties. We finally got all the cables freed up, so now we can pull this thing out of here. Okay, it's going to take over to the other desk and open it up. Okay, it's going to open this up. And the nice thing about these particular units is the clamshell case, which immediately gives you access to the bottom of the circuit board, so you don't have to do an in-depth teardown just to get to the bottom of the PCB. Alright, now this thing has been sitting unplugged for several days now, so we generally should not have any issue with stored power. In fact, these things generally discharge in seconds, but it's always a good idea to play it safe with these, because you don't want to get electrocuted. So we are good to go. So the suspect capacitor is this one right there. So that is the capacitor that is in charge of the plus 5-volt standby output filtering. And when that capacitor goes bad, the 5-volt standby rail cannot start up on its own under load. Sometimes even unloaded if the capacitor is bad enough failed, but this one has not got to that point. In fact, it's not even bulging on top. It's probably just dried out. The thing is, this capacitor is one I stuck in there probably 8 years ago, maybe longer than that. It's been a while. So let's go ahead and change that out. See, that capacitor was actually harvested from a motherboard, so it was actually not new. So it's one of the reasons why now when I recap power supplies, I generally use new capacitors when available. The secondary on this unit, it's a mixture of new caps and I think a couple of motherboard harvests. The secondary, I think I recapped at a later time. I think when I got this unit back out of the refurbished computer, which was still working, we had some failing caps over here on the secondary, but this Rubicon I stuck in there years ago was still working fine at the time. So that being said, I'm going to just change out this one specific capacitor, and that should get this thing back up and running. So let me go ahead and grab a replacement capacitor. Alright, so I'm going to fire up the soldering iron. Alright, so here's a replacement capacitor. It's a brand new capacitor. It's actually from 25th week of 2020. That was when I ordered a bunch of these caps. It's a 10 volt, 2200 microfarad capacitor, I think general purpose. The one that's in there is a 6.3 volt, 2200 microfarad, which the voltage on that cap is 5 volts, so it's not a super big deal to use 6.3 volts, but we're going to swap it out with a 10 volt capacitor. Take a moment to eyeball exactly where it's at, and I think it is right here. Could be wrong, let me double check. Yeah, it's definitely right here because I can tell these solder joints look a little different than the others around them. So we're just going to walk this cap out of here. Yeah, that's definitely it. Okay, it's out. Clean these leads off, because we're going to test that cap here in a little bit, see what its actual capacitance is. It could still read within spec, but it could have high ESR, which could be irritating this power supply a little bit. Grab my solder sucker, and I can clean out the holes. Okay, now let's go ahead and install our replacement capacitor. So if we look here, now we can see it right there in the center of the screen. Right down here is where it goes, and if you look carefully you will see on the circuit board is printed which side is positive, which side is negative. We want to make sure we get it installed in the correct direction. So on this unit, the side that has the hash marks is the side that's negative. And again, we want to definitely ensure that we install it in the correct direction. So on the capacitor, you have a stripe, and this one has a negative indicator. and it's also decided it has a shorter lead. Longer lead is positive, shorter lead is negative. Now, of course, electrolytic capacitors are polarized, meaning you have to install them in a specific direction. However, not all capacitors are polarized. I think electrolytic and tantalum are the ones that are polarized, whereas ceramic, like polyester film, and those types are not. They can go either way. So I'm going to feed the leads of this cap into the circuit board. That's one advantage of using fresh new capacitors, is that you have the longer leads to work with. And with this one, I'm not going to install it all the way through. I'm going to elevate it off of the PCB somewhat, and I'm going to try to sort of angle it a little bit. I'm going to try to keep it away from that heatsink, because that's what kills these things. It's a heatsink and a diode right next to it, so it's not so much a secondary heatsink. As a matter of fact, it's not really the secondary heatsink at all. It's there's a little diode down here, and it is. Let me pull this out for a sec. Can't see what designator it is, but there's glue on this thing, so I can't tell you the exact designation of the diode. However, the capacitor is C36. And it may also be the same capacitor designator on the Bestec 250-12Z and 300-12Z, because they are very similar in design to these 312Es. So I'm going to insert that like that. Keep it elevated off the circuit board a little bit. I'm going to bend these leads out, and what this will do is it will hold the capacitor in place. All we got to do now is just solder in the new cap. And then we'll sort of aim it away from that diode. That's the culprit. Okay, we are all done. Just gotta cut the excess leads off. Helps when your cutters are not dull. Alright. So I'll flip this over, and I'm going to aim this cap down a little bit toward the front. We want to get away from that diode. That diode is our issue. Let me make sure that this trace is not raised up at all on the PCB. Nah, it's good. If it was, we would have to put the cap right against the PCB, but we are okay. And just to verify, we have it installed in the correct direction. It's a 10 volt capacitor, so it exceeds the voltage of the circuit. It matches the cap we pulled out, 2200 microfarad. Okay everybody, so this portion of the video is being recorded 2 weeks later. So I put this power supply back together and put it back into the system, and of course it passed the back porch test, ran fine here. But then the following Monday, when I took this machine back to my workplace, it did not want to start up. It exhibited the same old buzzing sound, and I had to open the system up, remove the motherboard connection from the motherboard, and jump start this thing, let it run, warm up, and then plug everything back up to get it started. So we got it back here again, and this time I'm going to be replacing this cap right here. Now that's one I installed, I think last year, or I don't know for sure, but that capacitor there is of questionable quality. So it is a 220 microfarad 50 volt capacitor. It was installed brand new, but It's a questionable brand of capacitor. So essentially a colleague had some extra caps he didn't need and happened to have those 220 microfarad 50 volt caps, and that's one of the caps I sometimes need when recapping these power supplies. So let's go and get this capacitor out of there. And it's in kind of a tight spot on the board. There's two surface mount resistors right in the vicinity of it. Ooh, and this trace is actually pulled up a little bit. That would explain why I did not elevate this cap off of the circuit board. Alright, so we got the cap out. Now the capacitor is not bulging, but I do have some suspicion that maybe it's a culprit. Let's go ahead and remove the excess solder. Okay, so I got that capacitor out and it goes right there, and that is C50. So that is the other capacitor that tends to go bad in these things. I've seen several of these units have that capacitor bulge as well, and I think it's the output cap for the auxiliary supply. So the 5 volt standby, of course, is over here, but this transformer also feeds an auxiliary supply, and if either of those two capacitors fail, it will prevent that 5 volt standby from starting up. Thing is, last time I did not think that this capacitor here was the issue because it was one I installed not long ago as a new replacement, but I mean, it is a questionable brand. It's called LCC, 220 microfarad 50 volt. But anyways, I have some brand new Rubicon capacitors go in its place. Okay, so here's our new capacitor. As you can see right there, 220 microfarad 50 volt. Alright, so the cap will go in this way. The shaded side is the negative. Now normally I would elevate this cap off the board, but I'm a little concerned about this trace down here being a little loose on the board, so I'm going to have to stick it down right against the board. But what I've done here is I have moved, or I've bent over Q2 just a little bit. Didn't mean to bend it over as far as I did, but bend it over a little bit, and also going to bend over D. I think it's, I can't tell what the designator is, but there's a diode that's like right next to that cap, which ain't really budging like I had hoped. So I'm going to put this cap right down against the circuit board because the trace over here is a little loose. I think I noticed that last time I had changed that capacitor. So anyways, hopefully this Rubicon cap will last longer than that LCC capacitor. So we're going to solder that in. This is a little more tricky to do because there's so much stuff right near it. Got two surface mounted resistors right near it. We'll make sure that the solder flows where it's supposed to and not where it's not supposed to. Okay, So we'll trim these leads off and we'll put this thing back together. Okay, so a replacement capacitor for C50 is now installed. So what I'm going to do this time is I'm going to put this back together, and when I back porch test this power supply, I'm going to leave this power supply outside for a little while. It's 41 degrees outside. That's in Fahrenheit, of course. So the idea is to let this unit get nice and cold. Let it get nice and cold, and we'll see if the 5-volt standby will come up. But then again, we won't know for sure how it's going to do until we, of course, put it back into our system. Okay, so this unit's been sitting outside for probably 15 minutes or so. Again, 41 degrees outside roughly. Let's see if it'll start. Came right up. Alright, let's open the door. Let's try to start it again. Let's see if we hear any odd noise from it. Any odd buzzing sound like it made in the previous video. None. No odd noises at all. So hopefully this means that we found and fixed our problem. Let it run for just a little bit longer before I bring it back inside. Yeah, it might have been C50 all along, because the other capacitor, it tested fine, at least according to our capacitance meter. That doesn't take into account ESR, but we'll test the other capacitor in a moment and see what it's doing. Okay, so I got everything back together and the portal cube is back up and running. So you see here, there's a power supply running. So, before I wrap this up, I figured we would test the old capacitor, see what its numbers are. So first, in comparison, I have a brand new capacitor just like the one I had just installed in that power supply. So I got a little capacitor tester here, and I have this brand new capacitor just like the one we put in this power supply, 10 volt 2200 microfarad. I'm going to have to adjust this up to the 10 millifarad setting. And as I mentioned before, these capacitors are polarized, and that also applies to our tester. So that being said, make sure we insert this capacitor in the correct direction. And you can see we're at 2.194 or 2.18 or 2.19 millifarad, which is 2190 microfarads. So just a tad below, which is normal. These things I don't think have a very, very tight tolerance. Alright, so now for the capacitor that we just pulled out. Again, make sure we insert it in the correct direction. You can see it's 2.19, so it's actually a little closer, but the ESR is probably high on this cap, and that could be what is going on with it. So this little meter here does not measure ESR, it just checks capacitance. Still kind of useful though when troubleshooting these things, because when the caps fail, when they actually start to bulge and leak on top, their capacitance will go down generally, but their ESR goes up as well, which stands for equivalent series resistance. So these capacitors, generally, it's like a battery. You don't want to have a lot of internal resistance in them, otherwise they will not function as well. And of course, with this power supply, the 5-volt standby rail relies on this capacitor for filtering the output, and if this capacitor is acting up in any way, if it's dried out, if it's acting up in any way, it will cause issues with the 5-volt standby rail. Now on these Bestec 300-12E as well as the 250-12Z and 300-12Z units, if the cap goes bad, generally what happens is the 5-volt standby rail just won't come up. It won't turn on. Now of course with the Bestec ATX-300 12E, which is the infamous E-Machine motherboard killer power supply, those use an analog controlled 5-volt standby circuit, which critically relies on capacitors to regulate itself, and it has no protections. So when things get out of whack, the 5-volt standby rail skyrockets and fries everything. With these newer units, they just shut down. They don't fry what's attached to them. I've never seen a Bestec 250-12Z, a 312Z, or a 312E fry any attached hardware. They're generally very good for not frying stuff, but of course they do have their issues with caps due to that. Of course, I think it was C36 being right next to a hot running diode. So hopefully with this new cap, the way it's in there, it will not have any issues. And on the PortaCube case, which is in the PVX Pack 2, what's nice about it is you can install the power supply either upside down or right side up. Now generally in most computer cases, the power supply is mounted like this, where you can see the fan is on the right and the plug is on the left. The PCB is actually upside down, and when it's like that, heat tends to gather up on the PCB because of course heat rises. Now when you have it installed like this, I'd say the heat sinks are a little more effective, and heat of course rises off of the board. So my idea was putting it in with the PCB facing upward. Maybe it would help this issue, but of course maybe not. Who knows? We'll see how long this thing lasts with this capacitor. It may last the lifetime of this system. So anyways, that is replacing the failing capacitor C36 and a Bestec ATX-300-12E power supply. And before I wrap this up, we got a 250-12Z up here I can just look at. I'm not going to open it. I'm just going to take a peek inside and see if I can see the designator for that capacitor. And of course, in this unit, it is located in the same spot. So this one has a fresh cap installed. I recapped this unit a little while back. I did use harvested motherboard caps back in the day, but it looks like I used a new capacitor on the 5-volt standby. I think I recapped the 5-volt standby in this one after I had done the secondary on this thing. And if I can see in there, yep, C36, and the diode in this unit is placed in a different spot, and it's noted as D23. Sorry if you can't see that, but yep, C36, that's the same capacitor. And I'm assuming in the diode and the other unit is also D23. So anyways, again, very similar with this unit, but of course not being clamshell. The cover comes off the top, and then you gotta, on these units, you gotta take the plug loose, you gotta take the switch loose, you gotta take the LED out. See, rather you gotta desolder them from the PCB. I find it easier to just remove them. The fan, however, does have a plug. You just unplug the fan. A little more involved, but once you get the PCB out, it's very similar to repair. So anyways, hope you enjoyed it. Thanks for watching. Hey everybody, thanks for taking the time to watch this video from Computer Channel. If this is your first time, please subscribe to the channel and be sure to tick the bell so we get notified of new video posts. Please like this video if you enjoyed it, leave a comment, and share this video as well as the channel with your friends and get the word out. Also, I have a second channel, that's CubeComp MTDX. Over there you'll find videos about thunderstorms and weather, cycling, and videos about me personally. Feel free to subscribe over there as well if you like. Again, I really hope you enjoyed this video, and thank you so much for your support.